So for the first question, 1 mark question, which of the following graph represent position time graph of the particle moving with negative velocity? So a particle is moving with negative velocity. They have given xt graph and the slope should be negative. So then this is the graph. So option number B is the right answer. The second question, can a body have a constant speed and still have a velocity? Yes, in circular motion, the speed is the same at every point, but the velocity's direction keeps on changing. So that's about uniform circular motion is the answer. The third question, can a body have zero velocity and still accelerate? Ball thrown on the top actually has zero velocity, but still it's accelerating downward due to acceleration due to gravity at the highest point of the ball. That's the answer. The fourth question, can the direction of the velocity of the object change when the acceleration is a constant? An acceleration is a constant is acceleration due to gravity. The ball going up and the ball going down has the same acceleration due to gravity. However, the direction of the velocity is upward and downward. So let's go to fifth question. Is it possible for a body to accelerate without speeding up or slowing down? Yeah, in circular motion, okay, the body is continuously acting with centripetal acceleration, which is acting towards the center. So it is going with the uniform circular motion, which is uniform speed with the direction alone changing, in which the body is possible to accelerate. Every time it's getting accelerated in a circular motion. Sixth question. So under what condition the average velocity is equal to instantaneous velocity? And when the object covers equal distance in equal interval of time, then the average velocity, which is x2 minus x1 by t2 minus t1, or a delta x by delta t, in other words, will be equal to dx by dt, which is instantaneous velocity. So under what condition the average velocity is equal to instantaneous velocity? So uniform motion. Seventh question, in which of the following examples of motion can the body be considered approximately a point object? A railway carriage moving between two stations can be considered as a point object. Correct? The object's size is smaller when compared to the distance it's traveling, then we consider it as a point object. And then a monkey sitting on the top of the cycle, smoothly running in a circular track. A monkey is a point object. Okay, so A is also point object. Train B is about a monkey is also point object. C is a spinning cricket ball that turns on being hitting the ground is also a point object. So the tumbling beaker slipping off the edge, that will not be a point object. A beaker on the table with respect to a small room is definitely not a point object. So let's go to eighth question. Read each of the following statement carefully and state with reason an example, true or false. With zero speed at an instant may have non-zero acceleration. Yeah, ball on the topmost point. With zero speed may have non-zero velocity. As speed itself is zero, then velocity will obviously be zero, because the magnitude of speed, the magnitude of velocity is what is speed, and the speed is zero, obviously the velocity is certainly zero. Okay, so next, when with constant speed must have zero acceleration. No, circular motion has got constant speed but has got acceleration throughout. That is about C. With positive values of acceleration, speeding up. No, the positive value of acceleration doesn't mean always speeding up. If this is the origin, a car is gone here and it's trying to take a reverse, the displacement will be in the reverse direction, but however is putting a brake which is in this direction. To stop the car from going in reverse, the brake has to be applied, the force has to be applied in opposite direction, so acceleration in that case will be positive. Okay, in order to slow it down. So second, these are all 1 mark question. Let's go to 2 mark question. If the displacement of the particle x is equal to t square plus 5t plus 3, the velocity dx by dt is a 2t plus 5 meter per second is known as instantaneous velocity. At a time t is equal to 3 seconds. Velocity at a time t is equal to 3 seconds is 3 to 6 plus 5, so 11 meter per second. They are asking for average velocity. The average is x2 minus x1 by t2 minus t1, and between a time t is equal to 3 seconds and t is equal to 1 second. And so you substitute in x2 at a time period of 3 seconds minus x1 time period of 3 seconds by time period of 1 second by 3 minus 1. So substitute in x is 3, so you get 9 plus 15 plus 3, okay, minus 1 plus 5 plus 3 by 2, so it will become 27 minus 9 by 2, which is 18 by 2, which is 9 meter per second. Let's go to 10th question. The displacement of the particle along the x-axis is x is equal to 3t plus 7t square. Obtain the velocity and the acceleration. Velocity is dx by dt, which is 3 plus 14t, and the acceleration is instantaneous acceleration, which is just 14 meter per second square. So that's the velocity and acceleration. At a time t is equal to 2 seconds, the acceleration, whatever be the time, is going to be a constant, which is 14 meter per second square. So 11th question, a body travels the first half the distance with the velocity v1 and second half with the velocity v2. The average velocity. Whenever the distance is getting split into half, time 1 is to d by v1, and time 2, or d by 2 v1 and d by 2 v2, distance by velocity. The total time is t1 plus t2, which is d by 2 v1 plus d by 2 v2, which is d by 2 into 1 by v1 plus 1 by v2. So they are asking for average velocity, and v average is nothing but the total distance by total time taken, is d by 2 into 1 by v1 plus 1 by v2. So it's, when you take LCM, you get v1 v2 with the 2 going on the top by v1 plus v2 is your answer. So let's go to 12th question. The train moves at the speed of 30 meter per second. No, 30 kilometer per hour for the first 15 minutes. Then a 40 kilometer per hour for the next 15 minutes. And then 60 kilometer per hour for the next 30 minutes. So they've given like this. You can find the respective distance traveled by the train when you know velocity and the distance. Velocity and the distance you know. So you can find the time as usual. Let's try the total distance. 15 minutes, this is minutes, okay? Whenever you know the distance and the time. Distance and the time. No, speed and the time, sorry. Speed and the time, you can calculate the distance. Distance is, therefore 30 into the time is 0.25 in seconds, in hours, sorry, because this is in kilometer per hour, plus 40 into 0.25 plus 60 into 0.5, convert everything in hours, so you get 7.5 plus 10 plus 30, which is 47.5 kilometers the total distance, and the total time is 15 plus 15 plus 30, it takes 1 hour. So if they ask you average speed, the average is 47.5 by 1, so it's 47.5 kilometer per hour, as average speed or whatever. So let's go to 13th question. 13th question, a car is moving along x-axis. It moves from O to P in 18 seconds and then returns back to Q in 6 seconds. What are the average speed of the car in going from O to P, means the total distance. The total distance is given as this is the 360 to be the total distance. At P, that's 360. Distance travelled by the total time taken is 18. So the average speed for travelling to OP is 20 meter per second. Then O to P and then back to Q. They're asking for average speed. Average speed, Then is the total distance again, which is 480 because it's traveling from 360 back to another 120 distance. So total distance is 480 by the total time taken is 24, and so the answer is 20 meter per second again. Then the average velocity to travel from O to P is the same as because a straight line motion, the speed and the velocity will take the same value. Only when it comes back, the displacement changes to 240 by the total time is 24. In that case, it becomes 10 meter per second. That will be the average velocity in going from O to P and back to Q. So then the displacement changes and so value reduces. The 14th question, the position time is x is equal to A is 8.5 plus B is 2.5 into t square. The velocity is dx by dt, which is 5t meter per second, and acceleration is 5 meter per second square. On differentiating, then asking for velocity at a time t is equal to 0 will be 0 meter per second. Velocity at a time t is equal to 2 seconds will be 5 to 10 meter per second, substituting 2 here. What is the average velocity between time t is equal to 2 seconds? Average velocity formula is always x2 minus x1 by t2 minus t1. And you should substitute x2 between a time t is equal to 4 seconds minus x1 between a time t is equal to 2 seconds by 4 minus 2, and substitute an x formula, whatever t is 4 and t is 2 in this formula. So thus you will get 8.5 plus 40 minus 8.5 plus 10 by 2. So you get 48.5 minus 18.5 by 2 is equal to 30 by 2. Therefore, it's 15 meter per second. So let's go to next question. So then there's a 15th question. Explain clearly with example the distinction between magnitude of displacement over an interval of time and the total length of the path, which is distance. The difference between displacement and distance. Displacement, as you know, is the shortest distance connecting the initial point and the final point, or in other words, it's change in position. Whereas distance is the total path traveled. If the path is like this is A and this is B, the change in the position is what is displacement. But when this is, what is the distance? Distance is calculated by A plus B, the total path. When the body is going, this is A and this is B in a straight line path. In this case, the distance will be, displacement and the distance will be equal. Displacement will be equal to distance in this case. Okay. So therefore, you can say that the displacement is lesser than or equal to distance considering both of these cases. Okay, so next with examples, clearly with examples, example is this, a car moving like this. Next is going to talk about the second part, magnitude of average velocity and average speed. The V average is always change in position, x2 minus x1 by t2 minus t1, or delta x by delta t, which specifically means that it's displacement by time. And the average speed average is total distance by time, or total path traveled by time. Okay, so that's about this. And we can also say, since you know that the displacement is delta x is lesser than or equal to the total path taken, L is the total distance. You can also say delta x by delta t is lesser than or equal to the average velocity. When you differentiate this, you get this is average velocity, delta x by delta t. Then average velocity is always lesser than or equal to average speed. Average speed and average velocity is lesser than or equal to average speed. So in case they twist and turn the questions, you can answer this. So only when it is along the same straight line will the speed and the velocity take the same value. So let's go to next question. Next question is the 16th question. A body traveling along a straight line. I hope it's recording. Yeah. Body traveling along a straight line traversed 1/2 the distance d/2 with the velocity v0. The remaining distance is also d/2, but in that equal time they are traveling at a velocity t1 travels with the velocity v1 and t2 travels with the velocity of v2. It's not that the distance is not getting split, it's the time which is getting equally split. When the time is getting equally split, you find the distance in this distance is v1 into t1, this distance v2 into t2, which can be equated to the whole d/2, and so you can consolidate it's v1 and v2. The t1 actually is equal time, so you don't have to call it as t2, you call it as t1. So t1 into v1 plus v2 is equal to d/2. So t1 is equal to d/2 into v1 plus v2. So you know the time, total time taken, and you know that the average speed, the average velocity is total distance by total time taken. So d and d will get cancelled. So that's the 16th question. Once again. Oh no, the total time I have not calculated, I'm sorry. We have to still calculate this time. The time taken for this is t is equal to distance by 2v0. So therefore the total time is this time plus this time, which is d/2 v0 plus d/2 into v1 plus v2. So you take d/2 out, 1 by v0 plus 1 by v1 plus v2. And the average speed is distance by time, total time. D and D get cancelled. You take LCM, you get final answer to be 2v0 into v1 plus v2 by v1 plus v2 plus 2v0. Very, very important question, where it's a time which is getting split equally. You have to calculate the distance. So let's go to next paper, uniformly accelerated motion, an equation of motion. The first question, 1 mark question, give example of where x is greater than 0, v is lesser than 0, a is greater than 0 at a particular instant. The car going in reverse towards the origin, where since x is it's still in the positive side of x-axis, so you can say x is greater than 0. Okay, the velocity is in the negative direction because this is a positive direction. So then we can say velocity is going to be less than 0. And acceleration will be greater than 0 because acceleration will happen in this direction. Okay, so when you say x is greater than 0, the position is greater than 0. Give an example, car going on the reverse towards the origin where it started, from it started. Okay, when they ask for position alone, the position any time is not change in position for you to say that the displacement will be negative. It is just the position of the car, which is only to the right side. Therefore, we are able to say it as positive. I hope you understood. The velocity is negative and acceleration is positive. Okay, so let's go to next question. Is the sum number 1, which is a 3-mark question. Derive an expression of motion of v is equal to u plus at, s is equal to ut plus half at square, where the symbols have the usual meaning. We can so you can derive it using graphical method. This is u and this is v, and this is a vt graph, and 0 to t is the time taken. You can convert it into rectangles, and you can name it as OA. Let me name it in now. OA, B, C, D, E, F. So you know what is EB. EB is equal to AE minus AB, which is V minus U. You can see V minus U, that is EB. And what is OA is equal to CB is equal to time taken, because you know the slope of this graph, because it's a VT graph, the slope will get you acceleration which is opposite EB by adjacent OA or CB, and therefore it's V minus U by T. So A is equal to V minus U by T, therefore V is equal to U plus AT is the first derivation. To get the next derivation, which is S is equal to UT plus half AT square, do area of S is nothing but area of the rectangle plus area of the triangle. Area of the rectangle plus area of triangle. Area of the rectangle is U into T plus area of triangle is half into base, which is T, into height, which is V minus U. And you know from the first equation, V minus U is AT. Substituting here, UT plus half AT square is your S, and you got this derivation. Very important. Another way of deriving this using calculus method. If they ask you calculus method, you should start with A is equal to dV by dt, where is A instantaneous velocity. So you cross multiply A into dt is equal to dV and start integrating both sides, 0 to t and u to v. And integration of 1 dt is t. Integration of 1 dv is v. Integrated from u to v, upper limit minus lower limit is v minus u. So v is equal to u plus at. The second equation of motion is done with v is equal to ds by dt, multiplying and dividing by ds by dt. We'll start with a is equal to dv by dt and multiplying and dividing by ds and ds. This itself is velocity. A is equal to v into dv by ds. So dv is equal to v into dv is equal to a into ds. On integrating both sides from u to v, it becomes v square by 2 is equal to as. It's upper limit minus lower limit. So it's v square by 2 minus u square by 2 is equal to as. V square minus u square is equal to 2as is the second equation. This is using calculus method. So let's go to next question. The second question is to derive v square minus u square is equal to, what did I do? I got this by mistake. The other equation of motion is, like you write v is equal to ds by dt, and then cross multiply ds is equal to v into dt, where in the place of v you substitute u plus at into dt. Now take it in. Okay, now take this in. You get ds is equal to u into dt plus a into t into dt. On integrating both sides, u is coefficient, constant 1 dt is t plus a into t square by 2. Thus you get integration of 1 ds is s. You get this, all the three equations of motion. The second question has got v square minus u square is equal to as, which is using the calculus method. Is very simple here. They ask you using graphical methods. Area of trapezium. Area of trapezium is the form, area under the graph gives you displacement. What graph? Area under velocity time graph gives you displacement, which is half into s1 plus s2 parallel sides into height, half into u plus v into height is t. Instead of t from the first equation, you can write v minus u, v is equal to u plus at by a is equal to t. So when you write v minus u by a, you get v square minus u square by a is equal to s. V square minus u square is equal to 2as, and you get this equation using graphical method. So let's go to third question. A car moving along a straight highway having a speed of 126 km per hour into 5 by 18 will give you 35 meter per second. Is brought to a stop, which means the final velocity is equal to 0. After traveling through a distance of 200 meter, which is s is equal to 200 meter, what is the retardation of the car and how long does it take to stop the car? For finding the retardation, v square minus u square is equal to 2as. V is 0 square minus u square is 35, the whole square is 2a into s is 200. So with this you can calculate minus 1225 is equal to 400a. So a is equal to minus 3.0625 meter per second square is the acceleration. To find the time, you can take v is equal to u plus at. The final velocity is 0, initial velocity is 35. You found the acceleration to be minus 3.0625 into t. So 35 is equal to 3.0625 into t. T therefore is 35 by 3.0625, and the answer is 11.43 seconds. So let's go to the next question. The fourth question. A driver takes 0.20 seconds to apply a brake after he sees a need for it. This is called the reaction time of the driver. So this is a sum which deals with reaction time. After he sees his child crossing the road, he suddenly puts a brake. If he is driving a car at a speed of 54 km per hour and puts a brake, the car starts decelerating 6 meter per second square, which should be written in negative, but however, let's keep it like this. Find the distance traveled by that car after he sees the need to pull. So that reaction time is what they're asking. The car initially has a velocity of, they've given velocity is 54. That's the initial velocity, 54 into 5 by 18, which is 15 meter per second. So you're going to find the distance. Is v square minus u square is equal to 2as. V is 0 because it's putting a brake. U is just found out as to be 15v whole square is equal to 2, and to acceleration is negative because it's retardation, into s. With that I can find what my s is. Negative get cancelled. I get the value of s, which is 225 by 12, which is 18.75 meters. So once he stops the car after traveling through a distance of 18.75 meter. Now you have to, already he's initially, even before this is like when he starts decelerating, correct? The distance moved when he starts decelerating. But even before that, was he continuing to move? He was continuing to move at constant speed. Speed is 15, and he was moving initially, and for a time period of 0.20 seconds. A driver takes 0.2 seconds to apply the brake. In that time he would have moved some distance, right? That initial distance is u into t, 15 into 0.20, where he is not accelerating. That distance will turn out to be 3 meters. So the total time taken for him to completely stop the vehicle is 18.75 plus 3, which is 21.75. You should understand that the moment you put the brake, your car doesn't stop. It still moves through a certain distance, and that distance initially, even before you press the brake, you think in your mind that you have to put a brake, it would have traveled. After you put a brake, it would have traveled some distance, and the total time has to be calculated. So let's go to next question. So the next question is the fifth question. A bullet is traveling with a speed of 15 meter per second, penetrates a trunk and comes to rest. The final velocity, this is initial velocity, final velocity 0. Find the time taken for the retardation. So you know v square minus u square is equal to 2as. Final velocity 0, initial velocity 15 the whole square is 2 into a into, it's traveling through a distance of 0.4 meter, 0.4. So what is the acceleration? Is minus 281.25 meter per second square. So you get this as the answer. You know a will be negative because it's retardation. Then the time, they're asking for the time taken. V is equal to u plus at. What is v? 0. U is 15 minus 281.25 into t. Hence you can calculate time, which is 15 by 281.25, which is 0.0533 seconds. So let's go to next question. It's a 5-mark question. The sixth question. Two ends of the train moving with a constant acceleration passes a certain point with velocity u and v. Show that the velocity with which the middle point of the train passes, the middle point exactly crosses this position. At that time, what is the velocity? Which means to travel only half the distance, right? If the total length of the train is L, then half the distance will be just L by 2. They're asking you to find the velocity at that instant. You write v square minus u square is equal to 2as, where instead of s you write L by 2. Okay. So if you write v square minus u square is equal to 2a into L by 2, 2 and 2 get cancelled, you get an equation like this. where this is the velocity with which it's crossing the middle part. Okay, you clear? But so this is my equation. Actually, this is my equation 2. What will be equation 1? You have to involve the final velocity, because the proof is the velocity when it's crossing the middle part is u square plus v square, which is initial final velocity, by 2. So something like this. You would have to do something with the initial and final velocity. The time taken for the train to cross, this full train to cross, is v square minus u square is equal to 2al. Correct? This is v mean square. That's the difference. Correct? So what is al from here is v square minus u square by 2. So you can write a square as v square minus u square is equal to v square minus u square by 2. So cross multiply, 2v square minus 2u square is equal to v square minus u square. Two v square minus 2u square. Consolidating, but this is mean, right? This is the middle part, right? How can you consolidate then? You can't do that, right? So it's mean, the middle part velocity is what you're going to calculate. Take this to the other side, v square minus u square by 2 plus u square. Just do the LCM and you get v square plus u square by 2. So Vm therefore is root of v square plus u square by 2. And therefore you should take the whole journey for the whole train to travel across that point, and the middle part to cross that point, and use the formula v square minus u square. And then you substitute L and L by 2 respectively. You get the you can get the answer. 7th question. The car in a race car A takes a time t less than car B. So TB minus TA is equal to T. And the car finishes the point with the velocity V more than car B. Velocity of the car A is more than car B by V. Assuming these two cars starts from rest and going with a constant acceleration, this is going with an acceleration A1, this is going with an acceleration A2. Show that V is equal to T into root of A1, A2. So you know what is, you can calculate what is TA and what is VA. What is TA is TB minus T, and what is VA is V plus VB. You found the TA and VA, correct? And you also know what is VA. VA, let's use V square minus U square is equal to AS in both the cases. So you know that they are starting with initial velocities to be 0, starting from rest. So you know VA is root of 2A1 and the distance are the same, right? VB is root of 2A2 into S. So with this you get the distance travelled by the car A and car B, velocity of the car A and car B, final velocities, and you can also substitute S is equal to ut plus half at square. And you know the initial velocity here also 0. Distance travelled by the first car is half into A1 into time taken by A square. And from this time taken by A square is root of 2S by A1. And S is equal to half, same thing, half A to TB square. TB is equal to root of 2S2 by A2. You know what is specifically TA and TB. You know what is VA and VB. So you can substitute them in what for I wrote this, I don't know. I want substitute in this TB minus TA. T is equal to TB minus TA. What is TB? Is root of 2S1 by A2 minus root of 2S1 by A1, TA and TB substitution. And from this root 2 S only, constant only, no? S can be taken out common. Root of 1 by A2 minus root of 1 by A1. You can write like this also. So that is your total time. And you want you have the velocity and the distance. The distance is S by the time. Distance by time will give you velocity. Or they are asking for velocity only. The combined velocity is what they are asking. Okay. So I can take LCM here, root 2s, and this will become, this is A2 and this is A1, right? A2, A1. So the LCM becomes root of A2 into A1, only the denominator. Numerator becomes root of A1 minus root of A2 by root of A2 root of A1. And this is the total time, the time difference T, which I'm calculating, which is TA minus TB, whatever. Okay, and where is the velocity? Velocity is VB whatever is the velocity? VA minus VB. Let's do VA minus VB. What is VA? We have found it here. Substitute that. Root of 2 A1s minus root of 2 A2s. So from this, root 2s is common, root A1 minus root A2. So you get velocity by time when you divide. You will get velocity is root 2s into root of A1 minus root of A2 by root 2s into root of A1 minus root of A2 by root A1 root A2. Root 2s get cancelled. This is also get cancelling, and so you get root of A1 into A2, and so take the t to the other side. You found V to be t into root of A1 A2. This is the way to do the sum. So you should remember this, that you write these two equations. You don't have to write what is T and TB. This was quite unnecessary. So you use the formula, find what is VA. V is equal to V square minus U square is equal to A, S, because the distance traveled by them is the same. And S is equal to UT plus half AT square. Using these two formula, find VA, VB, TA, TB. Once you find that, you substitute in the given two equations and then divide, and you get able to get the proof that what is V. So that's a very beautiful sum. So let's go to the next question. Next question is the 8th question, where a car accelerates from rest. So U is equal to 0, with an alpha being the acceleration, after which decelerates through beta and comes to rest. The final velocity is 0. The total time elapsed is t seconds. Then calculate the maximum velocity that the car has attained. You know, in this point, what is the velocity? V is equal to U plus AT. You know that U 0, A is alpha. So the velocity at this point is the maximum velocity, which is alpha into t. The moment you do this, you should remember they're asking you to find the distance traveled, the total distance traveled, the maximum velocity. Maximum velocity is done. Immediately do a graph where it's a velocity time graph where the acceleration is alpha, the deceleration is beta, and you know that this is the maximum velocity, which is alpha t, which is V maximum, and you find the area under the graph, which is half into t base into height. Height itself is V max. That will give you your distance traveled. Okay, so but the thing is, yeah, so this is your answer, the total distance traveled in terms of alpha, beta and t, but what I found is V max. So then therefore use this journey, okay, and write what is the final velocity. V is equal to U plus AT, where initial velocity itself is alpha t. The deceleration is beta. Let's assume this is the time taken for this is t1, and let's assume the time taken for this is t2. So this will be alpha t1, considering this is time t1 and this is time t2. So you get a t1, alpha t1 minus beta t2. You get it like this, which is equal to the final velocity, which itself is 0. So alpha t1 is equal to beta t2. So beta can be written as t2 can be written as alpha t1 by beta. T2 can be written like that. Okay, and you know the total time is t1 plus t2. So t is equal to t1 plus t2. What is t1? Did we calculate t1? But answer can be, and first let's take this journey. Yeah, what is t1? T1 is V maximum by alpha. T1 is V maximum, which is alpha. Okay, you get it like this. After which, what do I do? So I wrote T2. Now I know that instead of this, can I do one thing? In small change, T is equal to T1 plus T2. So can I write T2 as T minus T1? Substitute it here. Alpha T1 is equal to beta into T minus T1. So alpha T1 is equal to beta T minus beta T1. Consolidate in T1, alpha plus beta into T1 is equal to beta T. So therefore you can write T1 as beta T by alpha plus beta. So you found beta in terms of T1 in terms of T. So you can substitute directly in this. To get the V maximum is alpha into T1, which is beta T by alpha plus beta. So this is your answer. Sorry for somebody is asking me some doubts. I had to get interrupted. Sorry. So then this is what it is. So let's go to the next question. Alpha beta alpha into alpha V maximum. What is the question? Is the distance traveled, right? Oh, here it is, distance traveled. So half into so distance traveled is what they're asking, and the distance traveled formula is this. No, this is just half into T1. It's just that area, right? The total distance traveled is half into T into height, which is V max square. T is T1 plus T2, the total time, which you can keep it as T, I think. That is not a problem. But V max square itself is from here you substitute alpha beta T by alpha plus beta. So it's alpha beta T square by 2 into alpha plus beta. Do you have an option like that? You have an option like that, then that's what you need to mark. Just look at it and tell me. So let's go to next question. The 9th question. The car is traveling from rest and accelerates at a rate of f to a distance s, then continues at a constant speed. This is acceleration. Then it's going at a constant speed, and then decreases its acceleration by f by 2 and comes to rest. So which means you can plot this as a graph, right? We can plot this as a graph where it's increasing acceleration, which is velocity time graph, then goes with a constant speed and then comes back to 0. The car starts from rest, accelerates f, and this is deceleration f by 2, continues for some time t. This time is t. if the total distance which is area under the graph is 5s. This area of trapezium, right? You don't know what is the total time taken for this journey, because we know that the constant speed for some time t. The car travels from rest, accelerates at the rate of f through a distance s, and you know this distance is s. And then continues at the rate. So I'm just thinking, can we find the time associated with this? Because I'm trying to use the formula half into s1 plus s2 into h. H is nothing but the velocity, maximum velocity, and I can find what is the maximum velocity during this journey. You know, what is this? V is equal to u plus at, and 2 in, or we can use initial velocity is 0, acceleration is f, and the final velocity is what you want. V is equal to ft, or otherwise you can use v square minus u square is equal to as. V square minus u square is equal to 2as, where this becomes 2fs. Initial velocity 0, v is equal to root of 2fs. So you understand that this velocity, final velocity, is root of 2fs, and it's traveling through distance s is equal to the constant velocity v for a time t. So let's keep this is traveling through velocity for a time t. It's moving with a constant velocity. Let's consider that it's going to be root of 2fs throughout into time t, and that's the distance through which it's moved during this. And during this journey, again I'm going to put v square minus u square is equal to 2as, and it's going to decelerate, and v is 0 and u square is this initial velocity, which is 2fs. The square is equal to 2 into f by 2 into that distance s3. Okay, so then 2 and 2 get cancelled. No, it becomes 4. So this is 2fs, whereas this is another distance. You can call it as s3. So you get s3 is equal to 2s. You get a relation. The distance between, let's take, we have taken this to be, this distance is itself 2fs into t. And this distance we are considering it as s, or s1. In other words, this is s1, and this is s2, which turns out to be v into t, and this is s3, which turns out to be 2s. So you calculate using v square minus u square is equal to 2as. For this it's constant velocity, so it's velocity into time. Thus you get the relation, and then you know you can find the total distance. S itself is s1 plus s2 plus s3. S1 plus s2 plus s3. What is s1? It's just s. What is s2? Is this distance, which is root of 2fs into t. What is s3? Is 2s. So this gets added, 3s plus 2 root of 2fs into t, and that's my total distance. And that is been given to be equal to 5s in the question. So root of 2fs into t is equal to 2s. Squaring both sides, 2fs into t is outside, okay? It's not within the root. T square is equal to 4s square. S and s get cancelled. 2 and 4 get cancelled. So you get s to be half ft square. So that's the proof, because they're asking you to prove it to be half st square. So since the proof is to find the total distance half ft square, I'm just trying to use everywhere v square minus u square is equal to as. V square minus u square is equal to as, and hence find what is s, because in this initial velocity is 0. This is the V max, or the maximum velocity with which it's reaching, which will turn out to be the initial velocity of the second journey. So V is equal to root of 2fs will be the initial journey, and it's going to travel with the same velocity throughout, and so the distance is velocity into time for this journey. And for this it is 2f by 2 into s3, and you know that the final velocity, the initial velocity of final velocity is 0, the initial velocity is this velocity, which is root of 2fs. That will be the initial velocity. So 2fs is equal to 2f by 2 into s3, so you get s3 to be equal to 2s. So therefore you found what is s1. This is, you've assumed it as s, otherwise it's not possible. This is s plus root of 2fs into t plus 2s is equal to 5s, which is given. So you're able to calculate. So what was the method I was trying is, this is traveling with f, and this is traveling like this. This is minus f by 2 is the acceleration. I was trying to think that this is a velocity time graph, and if I find the area under this graph, I'll get the total. But I'm trying to find the area half into s1 plus s2. This time is t, but I don't know this time, the total time, plus the small time, into perpendicular distance, which is V max, which I have already found. That I can find using even V is equal to u plus at, where V itself is u0, and so then I can write A to be f into t. So this is f into t. So I could have done like this, but the thing is, the time taken here is not t, because this is t. So I have to assume the time taken as t1, the time taken here as t3. So it's Vf into t1. That's the maximum velocity, ft1. But you don't want in terms of t1, you need it in terms of t. Okay, so I have to find the time of this journey. I have to find the time of this journey and then substitute it here, so that I get the total time. Correct? The small t is okay. This is all right. This is t1. The time taken for this journey is t1. This is t3. So just follow this method. Otherwise you have to find the respective times, but you won't answer only in terms of distance, no? So might as well do only v square minus u square is equal to as, and that's the most easiest method you can do and find the answer. So let's go to the 10th question. Then next is the 10th question. Draw the equations nth second. You know the derivation. You can derive. It's Sn plus 1 minus Sn. It's Sn plus 1 minus Sn, which is ut plus half a t square minus ut plus half a t square. Now expand this and cancel it to get u plus a by 2 into 2n minus 1, this derivation. And then derive an equation for the nth second is done. A body travels half its path in the last second of its fall from rest. So the initial velocity is 0. The last second, which we can consider as nth second, is covering half the distance, s by 2. It's u plus b square, ut plus half at square, u0. So it's s by 2 is the distance, g by 2 into, no, nth distance, it's not, it is nth distance, last distance, u plus a by 2 into 2n minus 1, where u itself is 0. So it's covering a by 2 distance. So in the s last is s by 2, which is g by 2 into 2n minus 1, or a 2t minus 1, considering the last time is t, last second is t. Okay, but you let's calculate the total distance covered. S is equal to ut plus half at square, where this whole thing is. So it's falling body, so I can write half gt square. That's the total distance, and in the place of this, can I write that? And I can convert this also to g. So it's half gt square by 2 is equal to g by 2 into 2t minus 1. 2 and 2 get cancelled, g and g get cancelled. And t square is 4t minus 2. So yes, you get a quadratic equation. You solve it, you get 2 plus or minus root 2. So you can't get a negative answer. So 34.4 seconds. 3.414 seconds should be your answer. So let's go to next question. It's a 1 mark question. The balls of different masses, one lighter, one heavier, are thrown vertically upward. We know it's independent of mass, right? So some initial speed, which one will rise greater height? We know it does not depend on the mass, so it will reach the same height. That's all. And you can put one lighter, one heavier, thrown vertically upward with initial velocity. The final velocity of both of them will be 0. You can use v square minus u square is equal to as, where the final velocity is 0. The gravity is going to pull it down. So s is equal to u square by 2g. The velocity which it's thrown by 2g. So that's all. Two balls of masses, one lighter, one heavier, are vertically upward. Which one will pass the point? A point at the downward direction. Which one is going to go at a greater speed? At the same point, they will cross with the same velocity. I think that's a question. I'm not clear with the question. Once again, that's it though. Two balls of different masses are thrown vertically upward with the same speed. Which one will pass through the point of projection in the downward direction with a greater speed? Same speed, it will descend also at the same speed. Speeds at every point, every level will be the same. Time of ascent is equal to time of descent. So we can say same speed and leave it like that. So let's go to the next question. And the third question, a foot pocket. We've done this in the class. It's rising. The helicopter is rising at 2 meters per second. The foot pocket will acquire the velocity of the rising helicopter. And so they're asking at a time t is equal to 2 seconds, what's the velocity? V is equal to u plus at, where velocity is used to minus 9.8 because the gravity is acting downward but the initial velocity was upward. So 2 minus 19.6 is minus 17.6 meter per second. The velocity can be negative because upward is taken as positive, downward will automatically be negative. How far is it below the helicopter? This distance at t seconds is v square minus u square is equal to as. They are asking for s. The initial velocity is not 0 here. It is it's taken upward velocity 4. The final velocity we just found 17.6. The whole square minus 4 or 2 square is equal to minus 2 into gravity is minus 9.8. That's why minus 2 into s. Therefore s is equal to minus 15.6 meters. So magnitude of s is 15.6. Why is it coming negative? Because upward is taken, displacement of the foot pocket is acting downward. So that's why we got it as negative. So let's go to the next question. The next question is the fourth question, I think. Fourth question. A ball is dropped from a height of 90 meters. When you say the initial velocity becomes 0. Okay. At each collision, the ball loses 1/10 of its velocity. So it retains 90% of its velocity with which it's striking. You find the final velocity. You use the formula v is equal to u plus at. U itself is 0. V is equal to gravity. Let's assume it is 10 or 9.8. So if you're going to assume it as 9.8, but you know the distance, therefore ideally you should use the formula. I'd like to use the formula v square minus u square. To find the final velocity, v square minus u square is equal to 2as. So v is equal to root of 2as. Final velocity is root of 2 into 9.8 into 90 is root of 1764 with the velocity which is striking, therefore is 4.2 meter per second. 17.64. Okay, and so it strikes the floor with 4.2 and it is going to bounce up with the 90% of 4.2, which is 37.8 meter per second is the velocity with which it's going to jump up, and that final velocity will be 0. You know the initial velocity of the second journey, and hence you can find the time taken for this journey, for which I think you can use you want the distance. What is the graph that they are asking you to plot? It all depends on that. Speed time graph, you need the time. So do you know the time for the first journey? V is equal to u plus at. U 0, V is 4.2, U 0, A is 9.8 into 2. So it's 4.2, time is 4.2. It's 42, right? This is 42, okay? 1764. It's 1764, so it's 42. So it's time taken is 42 by 9.8, which is 4.293. You found the time also. Time for the ascent. You got the time for the ascent. So first journey, you've done the time and you found the final velocity. Now you can find the time of the second journey, because you ideally need a velocity time graph. V is equal to u plus at. The final velocity is 0. The initial velocity is 37.8. And the gravity is going to act downward here, minus 9.8 into t. So the time is 337.8 by 9.8, 3.86 seconds. So that's over, and then it's going to come down. The ball is going to come down. The final initial velocity is 0, and you can calculate the final velocity with which the ball is time, and the velocity with which it's ascending will be the same velocity with which it's velocity at the time of striking, and it's going to again lose a 10% becomes 90% to bounce up. But what's the time taken for this? You write v is equal to u plus at, and you know u plus at, and u itself, the final velocity, it's coming down. So initial velocity 0, gravity is 9.8 into time is equal to the final velocity, which is 37.8. Again, it's going to time of ascent is equal to time of descent. It's also going to take 3.86 only. You don't have to calculate. So you know the initial time is time for the first journey is 4.293. For time for the second journey is 3.86. Time for the third journey 3.86. When you count all this, it will exceed more than 12. I think it gets 12.01. So this is enough to calculate, and we can spot the draw the graph. You know that it's going to reach a velocity of 42 within a time of 4.293, and then its velocity is going to drop a bit. It's becoming 37.8 from 42, and then again it's going to come down like this, and which is rising up, and the time taken for that journey is actually you have to add 3.86, and it becomes 8.15 or whatever, and then from the initial, these two has to be added, and then again it's rising similarly and stops there, and that's taken a time of 12.01. So they asked only for a graph till 12. This dropping is what you should show, very important. The fifth question, two balls are thrown simultaneously upward, the speed of 2 centimeter per second from a ground, or the ball A, and word B is downward from a height of 40 meter with the same speed. So this has got initial velocity 20 meter per second. It's not 0 even, it's getting pushed down, and this is going up with a velocity of 20 meter per second. along the same, let me read the question properly. The two balls are thrown simultaneously, vertically upward at speed of 20 meter per second, vertically downward from a height of 40 meter with the same speed. At what point do they both collide? Okay. So if you consider this is going to rise through a height h, this will come down through a distance 40 minus h, because the total distance is h. That's when it's going to collide. So when we're going to, the distance, s is equal to ut plus half at square. For this journey, h is equal to ut plus half at square. Ut is 20t. Gravity is minus half gt square. I used this formula and I found this height. For this journey, it's 40 minus h is equal to ut plus half gt square, because ball is coming downward, gravity has to be positive. But you know that you have a h and you can substitute that h. So it becomes 40 minus 20t plus half gt square is equal to 20t plus half gt square. This and this gets cancelled. 40t is equal to 40 and time is equal to 1 second. So thus you get the time to be 1 second, and you can substitute in this time as 1, and h is equal to 20 minus half into gravity, you can keep it as 10, right, into 1, so it's 5. So can I say 15 meters is the h, and the total height is 40, and that's the sum. So let's go to the next question. It's the sixth question. I hope it's recording. Yeah, sixth question. A balloon is ascending at a rate of 14 meter per second. So initial velocity of the foot pocket dropped will also be 14 meter per second at a height of 98 meter above the ground. When the foot pocket is dropped from the balloon, how much time and with what velocity will it hit the ground? You have the distance. You can write v square minus u square is equal to 2as. You can find the final velocity. The initial velocity is 14 the whole square, but it's upward, so gravity has to be minus 10 or a minus 9.8 into height is 98 meter. So with this I can find the final velocity. Are they asking for final velocity with which the ball hits the ground? How much velocity? Yeah, you know the distance, you know the initial velocity. Put in v square minus u square is equal to es. Make sure that you're writing s as negative, the gravity as negative, because it's 14 square. Yeah, just calculate this value, you get the final velocity. Okay, and how much time will it take? You can also use s is equal to ut plus half at square. It's s. The point is, the s has to be written as negative. If you forget to write s as negative, minus 19.8, because the displacement is in opposite direction, minus 98 is equal to ut minus half into 9.8 into t square, which is 4.9. With this you can get a quadratic equation and solve for time. This is very important. You proceed using this method, and thus you can calculate the time, or you can go for final velocity and even use v is equal to u plus at. How you do it is your wish. Let me tell you the final answer for this sum. You will get this quadratic equation to become 7t square minus 20t minus 140 is equal to 0. We solve this quadratic equation, you will get it like that. Okay, so 4.9 into 2, and you're multiplying throughout with a making it 140 with a 10 so that it looks good. So this is your quadratic equation. To solve this, you have to use minus p plus or minus. You get 6.12 second to be the approximate time. That's the final answer. And to get the final velocity will be it's a 14 minus 9.8 into this time 6.12. You can substitute this You'll get minus 46 meters to be the final velocity. You can do these two methods, or you could have used this and found the final velocity. You will get the same answer. You can verify, okay? So how you proceed is your wish, your thoughts, okay? So let's go to next question. It's the 8th question. A player throws a ball upward with an initial speed of 29.4 meter per second. That's the initial speed. What direction of acceleration during the upward motion of the ball? It will be downward. What are the velocity and the acceleration? Highest point. Highest point, the velocity will become 0. Acceleration will be downward, 9.8 meter per second square. When x is equal to 0 and t is equal to 0 is the location time of the ball at the highest point. And the vertically downward direction is taken as positive. Then give the sign conventions of the velocity and the acceleration of the ball. Position also. I told you the position anywhere here. It's not change in position. So you should write it as positive, downward. And then velocity. Velocity is in upward direction, right? So then velocity is negative. The acceleration is positive because it's happening downward. Okay, so that to what height does the ball rise and after how long? This is for upward moment. For the upward moment of the ball, whatever answer I said is correct. The ball is going to come downward. Everything will be positive. The position will be positive, velocity will be positive, and gravity will also be positive. So then they are asking for maximum height. You know, v square minus u square is equal to 2as. Okay, so you know v is 0 is equal to 29.4 the whole square minus 2 into 9.8 into h. H is equal to 44.1 meter. And then you can use v is equal to u plus 80, and you write v as 0. It's 29.4 minus 9.8 into t. Thus you get t is equal to 3 seconds. The total time of ascent is equal to time of descent. So total time is 6 seconds. So that completes that sum. Which sum I'm in? I'm in the 9th sum. A boy standing in a stationary lift throws a ball upward with a maximum speed of 49 meter per second. How much time does the ball take to reach? It has to go and come down. You know, time of ascent is equal to time of descent also. Okay. If the 9th question, if the lift starts moving up with a velocity of 5 meter per second, the boy again throws the ball up with a maximum speed. How long does the ball take to return to the sand? Okay, so lift is also going up. Okay, the boy inside is throwing a ball up. Boy standing in a stationary lift throws a ball. Stationary lift only, no? Throws a ball upward at the maximum speed equal to 49. So when stationary, it will reach what height? S is equal to ut plus half at square. U itself is 49t minus half into 9.8 into t square. But the net displacement is 0. With this you find time to be 10 seconds when it is stationary. But there's another part, no? The second part of the question is where it gets difficult. The lift is also moving up and then he throws the ball. Okay, but he's saying it's moving upward with a constant speed. Does it say that? Of 5 meter per second, so there's no acceleration. And you write v is equal to u plus at, acceleration is not there. There's no acceleration. Okay. See, in this question, I'm not supposed to find the relative velocity and add up these two velocity. Why? Because the ball is thrown up by the boy and is received by the boy. Everything is with respect to the boy only. The lift may move up or down, but the boy's throwing velocity remains the same. So can I consider the initial velocity to be the same? This is where I am finding it difficult. Ut plus half at square, where it's still 49t only, minus half into 9.8 into t square. Still the time is only 10 seconds, which is same as before. Because of the frame of reference. The initial frame of reference is everything is with respect to the boy. This is with reference to the boy. Okay, so we don't add. When do we add? When it's reference to viewing from outside. Then there will be the ball and the lift velocity must get added. Then in that case, you have to write it as 54. The initial velocity itself is 54 and you write 54t minus 4.9t square is equal to 5t. See, you must understand that this question very clearly, very important question, they didn't ask this part. The lift here acts as an inertial frame of reference because it is not accelerating. And so we should just not add the two velocities. Okay, that part is tough and that part is so important. So let's go to the next question. So when does it get returned to the hands? So when you say displacement is 0, so the total time is 10 seconds. So next question is non-uniform accelerated motion. The first sum, the velocity of the particle is given to be v is equal to 2t into 3 minus t. Take it in 6t minus 2t square. 60 minus 2t square. The dv by dt is equal to 6 minus 4t. So you have 6 minus 40. What are they asking? What's that? At what time is its velocity maximum? If you want to find what time is the velocity maximum, you should know dv by dt should be equal to 0. That's when the velocity, in a velocity graph, the maximum occurs when the slope is equal to 0. So this is equal to 0. 6 is equal to 4t. T is equal to 3 by 2 or 1.5 seconds is the answer. That's the answer for the first question. The second question is the velocity of the particle v is equal to 2t square plus 5. Okay, so then they're asking for instantaneous velocity. Dv by dt is 4t. At a time t is equal to 4 seconds is 16 meter per second. Then what are they asking? They're asking for the change in the velocity between time t is equal to 4 seconds, t is equal to distance v2 minus v1. v2 is time 2 seconds and minus v1 is for time 4 seconds and 2 seconds. Just substitute it. It is 32 plus 5 minus 8 plus 5. So you get 37 minus 13 is equal to 24 meter per second. Then they are asking average acceleration is v2 minus v1 by t2 minus t1 between a time 4 seconds. Between a time 4 seconds minus 2 seconds, is it? 16 minus, let me read the question, the second part of the question. The average acceleration during the same time interval, so v2 at a time of 4 seconds minus v1 at a time of 2 seconds by 4 minus 2. Velocity is 4t. What is, oh no, you can't put in instantaneous velocity. You should put t is equal to 4 here. So, because that's the equation, v into 4 plus 5. So, 2 into 4 plus 5 minus 2 into, no, this is 16. And this is 4 plus 5 by 4 minus 2. So, this will be 18 plus 5, is it? 32 plus 5, 37. This will be 8 plus 5, which is minus 13. 34 minus 13 is 21 by 2. Getting answer is 10.5. Because they are not asking instantaneous acceleration. If it's instantaneous acceleration, you differentiate this, you get 4 meter per second square. They are asking for average acceleration. Its formula is v2 minus v1 by t2 minus t1. Oh, I thought we found this to be 24 v2 minus v1. So isn't it merely 24 by 2? Am I not making some mistake here? 32 plus 5, 37. Yeah, 37 minus 13 is 24. So it's correct, it's 12. Okay. So I hope you have done this sum correctly. Don't think it's instantaneous acceleration. And change in velocity also found, average acceleration found. Next question, one more question. Which of the following graph represent uniform motion? Is ST graph, which is a straight line, represents uniform motion. So the next question. The next question has got 4 graphs. They're asking when will the velocity be maximum? An xt graph for which the graph goes like this. This is where the dx by dt is equal to 0. That's when the slope, the velocity becomes 0. That's a point at which velocity becomes 0. The average velocity over time can vanish at this. So the graph is this, which is B is the option. Let's go to next question. Next question is the second question. 2 trains A and B. This is a 100 meter. Another train is also 100 meter long train. Both of them are going in the same direction. And the time given is 20 seconds. Moving the same direction. For this train to cross this train, it would have traveled 200, because to come here it should cross this 100 plus additional 100, because the driver has to come here, the guard will be here, this is the driver. So then it's 200 by 20, which is just 10, which is VA minus VB, and the relative velocity. And for the train which are going in the opposite direction, it is always VA plus VB. And for this again, it's same distance, 200 by the they've given the time to be 10 seconds, so 20. So you know VA minus VB is 10, and a VA plus VB is 20, like a linear equation. 2 VA is equal to 30, so VA is equal to what is it? VA is equal to 15 meter per second, and hence VB will be 5 meter per second. You can calculate this question. Let's go to the next sum. Next sum is the third sum, where they've given 2 slopes. They are asking, there's an xt graph which has been given. The slope of one which tan 60, the slope of the other is tan 30, and you know the speed itself is a slope because VA by VB, this is B and this is A. So VA by VB itself is tan 30 by tan 60, which is 1 by root 3 by root 3, which is 1 by 3. So that's the ratio. So can I go to the next question? So you know obviously which is having a greater speed. The B is traveling with a greater speed because its slope is greatest. And let's go to the fourth question. The woman starts from home. Recording stopper. Fourth question. Woman starts from home at 9 a.m. walks at the speed of 5 km per hour. அப்படி ஒரு sum இருக்குல்ல, this sum, she walks like this from home. She walks 2.5 kilometers away is the office, and she starts at 9 o'clock and she walks with a speed of 5 km per hour. You can immediately find the time. Time is distance by velocity. Distance is 2.5 by 5, which is 1.2, which is half an hour. So 9:30 she'll reach office. Then she's going to stay in the office till 5 p.m. At 5 p.m. she's going to go back, but she's taking an auto. So the speed will be steep. Okay, and this auto is going at a speed of 25 km per hour. Distance is just the same. Speed is 25. So you get the time to be 1 by 10. And it is into 60. So it takes 6 minutes. So therefore 5.06 minutes she is reaching home and complete the graph. That's all is the question. So let's go to next sum. So let me continue with the recording. In the fifth sum, if you see the scooter is going through a distance of area under the rectangle. Okay, the area of the rectangle is 15 into 30, which is 450. And that will be the distance traveled by the scooter. And till that common point, distance covered by the car paklam. The car distance is area of a triangle, which is half into 15 into 45. So you get this, which is area of the triangle. Is it area of triangle? Correct? Distance, yeah, until they meet at the point A. Until they cover the equal distance till 15. For 15 seconds, the car would have gone like this and the scooter would have gone like this. The area under the triangle and area under the scooter and area under that's what we are trying to find initially. And after which, if you see, the car is stopped. After which the car is stopped. That's why, no, actually after which the car is let's see what has happened. There is also, the first question is the difference in the distance traveled by the car and the scooter. So you have to subtract both of this. When you subtract both of this, you'll get half into 15 into 45 minus 450. You'll get answer to be minus 112.5 meter. Okay, so that's the magnitude. You can take the magnitude. That's the distance between the distance traveled. And then they cover the same distance and they're going to overtake at some point. It's going to overtake, so you get a scooter. So S is equal to ut plus half at square, where u is 30t. Okay, just at the point where the scooter is going to go with a constant velocity after that point, and there's no acceleration for the scooter. And then because it's a velocity time graph, okay, so then the distance moved by the car is ut plus half at square. Okay, and for the car also is going to go with the car again is accelerating in order to overtake. Did they give anything like that? They cover the same distance, they can overtake. If they cover the same distance only, they can overtake. Correct? Only after that they can overtake. So initial velocity of the car is 0 according to the graph. This is car's velocity. Can you see 0? So you have acceleration which is opposite by adjacent. This is opposite and this is adjacent, which will be 45 by 15, which is 3 into t square. So distance traveled by the car S is equal to 3 by 2 t square, and distance traveled by the scooter is 30t. And these two distances have to be equal for it to be overtaking. So 30t is equal to 3 by 2 t square, and t get cancelled, and t becomes 20 seconds, and that's the answer for this question. So let's go to next question. Distance time graph an object in the case of body at rest. The body at rest xt graph is just like this. Then xt graph for the next question is like this. Xt graph for this is like this. Okay, so next is the graphs again. A seventh question. The xt graph is like this. The vt graph is like this, and the at graph is like this. So let's go to eighth question, the drunkard question. The net displacement is 2 because he takes 5 steps forward and 3 steps backward, 2 meter. The time taken for every net displacement is 8 seconds because every step takes 1 second. And considering that there is a at a time you just find how many cycles he goes and comes back. If it takes 4 cycles, the net displacement will be 8. So in 4 cycles, the net displacement is 8, which means he's keeping 32 steps totally. And from the 8th position, If we add another 4 steps, he'll fall into the pit. Correct? So then therefore, plus 5 steps, he'll fall into the pit. So then add a plus 5 seconds, it will be 37 seconds is the total time before which he falls into the pit. So let's plot the graph. At time t is equal to 5, x is equal to 5. At a time t is equal to 8, x comes to 2 because he returns back. At a time t is equal to 13, x is equal to 7. Time t is equal to 16, x is equal to 4. Time t is equal to 21, x is equal to 9. T is equal to 24, x is equal to 6. And t is equal to 29, x is equal to 11. T is equal to 32, x is equal to 8. T is equal to 37, x is equal to 13. And he falls into the pit. So let's see how to draw this graph. So mark it as 0, 5, 10, 15, 20, 25, 30, 35. And do it as 2, 4, 6, 8, 10, 12, whatever. And then you see that at a time t is equal to 5, x is equal to 5. At a time t is equal to 8, x is equal to 2. At a time t is equal to 13, x is equal to 7. At a time t is equal to 16, 16 is here, x is equal to 4. You understand? Like this it has to go on. And then at a time 21, x is equal to 9. At a time t is equal to 24, which is somewhere here, x is equal to 6. At a time t is equal to 32, 24, 32, x is equal to 8. At a time t is equal to 37, 27, 8, 32, something is missing, 29, 11, 29 is here, it goes to 11, then 37, 13, 32, 8, 37, falls into the pit. This is how the graph is. Okay, let's go to the next question. Sum number 9. They've given a graph like this. You draw a line parallel to y-axis. You can't be in two different positions at the same time. You can't have two different velocities at the same time, positive and negative velocity at the same time. Speed time graph. Speed can never be negative, so this is not possible. So all these graphs are wrong. This is possible. Let's see how this is total path. How can path decrease over time? Total path not possible. So this is also wrong graph. So let's go to the next question. It's the 10th question. They've given an xt graph which is like this. Okay, this shows that when t is less than 0, the particle is stationary. There's no graph. The particle is stationary and is uniformly accelerated because the velocity time graph will be a straight line like this. The velocity and acceleration time graph will be a constant. The uniformly accelerated freely falling body. That's the answer for this question. Okay, so let's go to the next question. It's the 11th question, where you have a graph which is like this and like this. This means a ball is going and hitting the wall and then immediately reversing its direction. It goes back beyond the thrower and hits another wall and then stops. That's the xt graph. So a ball is thrown directly to a nearby wall. It travels with a constant speed, bounces elastically off the wall with the same speed, goes past the thrower, hits the barrier and stops. The second one is a velocity time graph which is like this. I told you this is a ball which is getting bounced from the floor. The ball rises. The velocity becomes 0 at the topmost point. The rising ball and the downward graph are the same. And then returns back, loses some energy, Okay, so the answer is ball rises velocity 0 and returns back, loses energy when it hits the floor, and keeps bouncing again and again. And this is the graph. So next graph is an acceleration time graph where it's like this, which means there's no acceleration here. Acceleration is 0 most of the time. Only for a small instant of time delta t, there's a sudden acceleration rise and decrease, and the direction changes, which is like a cricket ball being hit by the bat. Okay, for that instant, the ball is going with a constant velocity, then hit by the bat, so then the acceleration suddenly reverses its direction. Okay. Also, next question is they've given a graph like this, some graph like this. Okay, they're asking what is the time at t is equal to 0.3 second. Observe the graph. X is negative, v is positive, a is negative. Observe from the graph. Okay, and the time t is equal to 1.2 seconds. X is positive, v is positive, and acceleration is negative at a t is equal to minus 1.2 second. X is negative, v is positive, and acceleration is positive. Let's take minus 1.2 second, which is somewhere here, this part of the graph. You know that it's an xt, this is an xt graph, so you know clearly that the time is negative. Yeah, position is also negative. And what about the velocity? You do a slope for this. Is it increasing slope? So velocity is positive. The acceleration is also positive. Okay, because at that instant, if you see, the velocity is increasing, so acceleration is positive. So next is the acceleration time graph for that will be like this, so it's positive. So let's take this for example at a time 1.2 second. Where is 1.2 second? Somewhere here. You see the graph, x is positive, the slope is positive, velocity is positive, acceleration will be negative at a time 1.2. Why is acceleration negative at a time 1.2? Because it is moving away from the mean position, and so the restoring force will try to bring it back to mean position, and therefore the acceleration is negative. Oh my god. In this case at 1.2, it's going again here. In the last one, the question was on minus 1.2 second. In minus 1.2 second is somewhere here. It's going away from the mean position only. The acceleration itself is negative. Actually, a is equal to minus omega square x. If x is negative, the acceleration becomes positive. If x is positive, the acceleration becomes negative. You should remember this formula. A acceleration is given by in a simple harmonic motion. This is like a simple harmonic motion, a sinusoidal graph. And this formula you should remember. Okay, so you can then therefore write everything. So let's go to next question. There's a graph like this, and the graph itself is not clear for me. So I'm writing whatever answer I there's a region 1, 2 and 3. The 3 has very steep, highly steep, and so the velocity is maximum. And where is the velocity minimum? And less steep is at 1. So okay, the greatest in the third. So greatest velocity happens in the third position. Lowest velocity, I am considering it as the first position, depending on this graph, because the slope is least here. And regarding the velocity is for sign convention, velocity is positive in the first one because the xt graph. The velocity here also is positive. The third one, the velocity is negative and maximum. Okay, so that answers this question. So let's go to the next question. There is a distance traveled in nth second. Y-axis is distance traveled in nth second. Oh my god, this is a beautiful sum. Okay, they ask you this. This is the n seconds. You know what is the formula? N is equal to u plus a by 2 into 2n minus 1. This is the formula for distance traveled in the nth second. And so u is 0, so s is a by 2 into 2n minus 1. You put n is equal to 0. This is, take it in. 2 and 2 is n minus 0.5. This is s, and put n is equal to 1, you put, the distance will become 0.5. N is equal to 2, you put, the distance will become 1.5 meter. N is equal to 3, you put, and the distance will become 2.5 meter. Then n is equal to dot of 10, you put, distance becomes 2.5 meters. So you get various distances, s1, s2, s3, s4. The distance is traveled at those seconds, and with that you can just plot the graph. N is equal to 1, n is equal to 2 is 1.5. So you write 2, 4, 6, 8, 10, 12. And this is also 2, 4, 6, 8, 10, 12. So you know that the graph goes like this. 1 second, hold on, let me read the question for you. Draw the xt graph. Time 0.3 seconds. No. That's the question, is it? No, that's not the question. Yeah, 2 stones. No, that's not the question again. Where is this question? This is the 14th question. The three-wheeler starts from rest, accelerated speed of 1 meter per second square in a road for 10 seconds. So your acceleration and time has been given. So you can find v is equal to u plus at. You know initial velocity is 0, 1 into 10. So you know the final velocity is 10 meter per second. Okay, that's the final velocity. And plot a graph. Distance traveled in the first second is 0.5. Distance traveled in the second is 1.5. Distance traveled in the third second is 2.5. So with this we can plot this graph, right? This is a distance traveled in the nth second. So with this you can plot this graph. This graph will turn out to be like this is at what is the distance traveled in the nth second? It's 10 minus 0.5 is 9.5. Okay, change it. So it goes up to 9.5, and 9.5 will be somewhere here. This is 6, 8, and 9.5 here, and the graph is going to go like this. And once it reaches 9.5, it's going to go with constant. It's going to become a constant y. During the then moves the uniform velocity, which means there's no acceleration. The acceleration itself becomes 0. Then in the further displacement also becomes 0. Acceleration becomes 0, then the further increase in velocity becomes 0. So it stops with the 10 meter per second square that it's acquired. It will stop with that, and this is the way that the graph has to be drawn. So let's go to 15th question, where the speed time graph has been given 0 to 5 and 5 to 10. What is the average speed in interval A is 0 to 10. You know that they've given it as 12. Speed is